April is the cruelest month, presented by Science at NASA. In the opening lines to The Wasteland, T.S. Eliot wrote, "April is the cruelest month." You might agree if you live in the southeastern United States. Last April, a historic outburst of 202 tornadoes turned broad swaths of that part of the country into a disaster area. The event of April 27th and 28th, 2011, was the costliest convective storm in U.S. history, said Kevin Knupp, professor of atmospheric sciences at the University of Alabama, Huntsville. It wasn't just costly in terms of property damage. 316 people lost their lives. Of the 202 twisters that day, 62 tore through Alabama where Knupp works. 10 of them were ranked EF 4 and 5 on the enhanced Fujita scale. 3 tornadoes churned paths more than 120 miles long, and a large number of the twisters cut swaths more than a mile wide. Knupp saw the results firsthand, and he's been studying them ever since. Aided by a team of graduate students and colleagues, he's sifted through gigabytes of data collected by NASA and NOAA satellites and local ground sensors. A year later, they have drawn some interesting conclusions. One discovery was how rapidly an EF5 spun up near the small town of Hackleburg, Alabama. The Hackleburg storm got its act together really quickly, says Knupp. This particular twister formed only 50 minutes after the underlying thunderstorm appeared. For comparison, the average time for tornado formation is 2 hours. The twister blasted through North Alabama with winds over 200 miles per hour, killing 72 people. Knupp's team believes that something called a thermal boundary set the stage for the birth of this killer. Cool, moist air on one side of the boundary formed a low cloud base, kind of like a wall, he explains. Warm air from the storm ran into the wall and swept upward. Updrafts are a key ingredient of tornadoes. In this case, updrafts as swift as 75 feet per second were recorded. They also noticed that many of the tornadoes seemed to cluster in space and time. Knupp offers the example of Arab and Guntersville, neighboring communities not far from NASA's Marshall Space Flight Center. 16 tornadoes touched down in the area, 13 of them in a half-hour period. Could local topography have attracted the twisters? There does appear to be a link between the shape of the landscape and the path of these tornadoes. For instance, many damage tracks began on the downward slopes of mountains where winds are naturally fast-moving. The team also found signs of tornadoes moving through valleys where winds were channeled like a breezeway. This tornado topography hypothesis might seem obvious, but researchers have not always had enough data to test it. That is, not until April 2011. Team member Tim Coleman, also at the University of Alabama, Huntsville, has searched tornado paths all over the southeast for repeats and found them. For example, just north of Birmingham, he found a tornado-damaged path crossing a road just 3 miles from where a previous path crossed. More research is needed to see if topography really plays a role, cautions Coleman. The more we can learn, the more accurate we can make tornado warnings. They're likely to get more data in the near future. It is April, after all. For more news about storms, on Earth and beyond, visit science.nasa.gov.